Hello everybody, this is Dr. Nurbat Shah from University of Engineering and Technology. I welcome you to my YouTube channel. So this is a continuation of lectures related to Laplace transforms. It's a second part in which we'll be talking about solution of ordinary differential equation by using Laplace transform. In last few lectures, we discussed how do we find Laplace transform of different type of functions. Now it's time to discuss to cover the area uh, where we use Laplace transform for solution of differential equation. Okay, so how does it work? Let's talk about that first. You see, you will be given a differential equation, say dyt that is equal to f of t, which could be a first order, it could be a second order, it might be third order as well. Right, we may go for fourth order differential equations as well. Our main focus will be solution of second order differential equations by using Laplace transform. So the first step, you will be looking for an initial value problem in which the initial condition will be given as well. So the first step is, what do? We simply apply Laplace transform on both sides, and that will convert the differential equation into an algebraic equation, right? And then we will solve that algebraic equation for Laplace of y, right? Because the algebraic equation will be having a variable Laplace of y of t. So we solve this algebraic equation for Laplace of y. So we can have Laplace of y as a function of s now, right? But our aim is to find solution of the given differential equation, and solution of the differential equation will be y of t. So we need to find y of t. For that purpose, obviously we'll be applying Laplace inverse on both sides. So applying Laplace inverse, we will be getting y of t, which is equal to Laplace inverse of g of s, right? So that will be the solution of the given differential equation. Keeping in mind, in this case, we find particular solution directly. We don't need to find complementary and particular integrals separately. All the solutions will be found simultaneously, even though the initial conditions will be applied during the process. Let me explain this process by an example. Before we move toward example, differential equations that contains derivatives, and we discussed in last few lectures that Laplace transform of derivatives of function can be defined in the following way. The first one is Laplace transform of y dash, which is simply equal to s Laplace of y minus y of 0 for the first order derivative. We'll be using that in later stages. Similarly, Laplace of y double dash, which is equal to s square Laplace of y minus sy of 0, and then we have y dash 0. For third order, it will become s cube, then we have s square with y of 0, then we have s, then we have y double dash at the end. If we go for the fourth order, so it will be s power 4 Laplace of y, s cube y of 0, s square y dash 0 minus s y double dash 0, and then we will be having minus y triple dash 0. Okay, so we'll be using these values of Laplace transforms for y dash, y double dash, y triple dash, y4 derivative, and so on. It depends upon the order of the differential equation. Okay, so let's go for the solution of a differential equation in example. Let's suppose we are given a differential equation y double dash plus 5y dash plus 6y is equal to 0, which is a homogeneous differential equation with initial conditions y of 0 is equal to 2, y dash of 0 is equal to 3. So as I said, the first step is what? We'll be applying Laplace transform on both sides. Laplace transform is हमने discuss किया था कि it's a linear operator. So we simply apply Laplace transform on both sides, like Laplace of this whole term on one side, the same thing here as well. It's homogeneous, so Laplace will be 0. Okay. So altogether we'll be having Laplace of y double dash plus 5 times Laplace of y dash plus 6 times Laplace of y is equal to 0. We have applied linearity property of Laplace transform. And then using the values of Laplace of y double dash discussed in the last slide, and the same thing for y dash as well. So putting the values of these, we get s square Laplace of y minus s y of 0 minus y dash 0. You know, y of 0 is what? That is 2, so this will be replaced with 2, this will be replaced with 3, whereas this will be replaced with 2 as well. And combining these together, because our interest will be solution for Laplace of y of t, because now we are having an algebraic equation. There is no derivative involved in this equation now. Okay, so combining them together, what do we have? S square plus 5s plus 6 into Laplace of y minus 2s minus 3 minus 5 into 2. The value of y of 0 is 2, so we get this one. And after simplification, we get what? This is minus 2s minus 13, and solving this for Laplace of y, so we'll leave this one to the left and the rest to the right to get Laplace of y. So Laplace of y is what? That is 2s plus 13 divided by s square plus 5s plus 6. Now to find Laplace inverse of this function, what would we do? We'll be simply finding partial fraction for it, जिसके लिए हम क्या कर रहे हैं? इसकी factorization करते हैं. So it's simple, इसको factorize कर सकते हैं. S square plus 5s plus 6 can be written as s plus 2 into s plus 3. And then by using a shortcut method to find the partial fraction for this one, and that is what, if you want to find, because usually you express this one as a divided by s plus 2, right, plus b divided by s plus 3. ओके तो जब इसको हम फाइंड करेंगे तो उसके लिए क्या होगा, जब a की वैल्यू जब हमें फाइंड करनी होती है तो उसके लिए हम यहाँ से a s प्लस 2 को ख़त्म करते हैं. यूजुअली हम कहते हैं कि डिवाइडिंग द डिनोमिनेटर ऑफ लेफ्ट हैंड साइड बाय s प्लस 2, तो इसको हम s प्लस 2 से डिवाइड कर देते हैं. बाकी जो रह जाता है उसमें s की जगह माइनस 2 ही पुट करते हैं. एंड माइनस 2 कहाँ से आता है? वेयर एवर दिस इज 0. Okay, so we get 2s plus 13 divided by s plus 3 at s equal to minus 2. Similarly, जब हम b की वैल्यू को फाइंड करेंगे तो उसके लिए हम क्या करते हैं? we divide this by s plus 3, मतलब इसको निगलेक्ट करेंगे और ये एज अ होल अप ले लेंगे. ठीक है, और s की जगह माइनस 3 पुट करेंगे. माइनस 3 कहाँ से आएगा? where this quantity is 0. So we put s equal to minus 3. So when you do that, what do we have? You'll be having value of this is what? 2 into minus 2 is minus 4 plus 13, that is 9, whereas minus 2 plus 3 is 1, so we get 9, and 1 over s plus 2. Minus 7 is because of this. 2 into minus 3 is minus 6 plus 13 is 7, divided by minus 3 plus 2, that is minus 1, so we get minus 7. So this is the value of a, right, जो हमारे पास partial fraction में होता है, whereas this is the value of b, जो हमारे पास partial fraction में होता है. So we have Laplace of y that is equal to 9 into 1 over s plus 2 minus 7 into 1 over s plus 3. You must keep in mind, you should remember that कि Laplace inverse जो है वो भी linear होता है. तो अगर हम यहाँ से Laplace inverse लेके आते हैं, so we'll be getting y is equal to Laplace inverse of 1 over s plus 2 minus 7 times Laplace inverse of 1 over s plus 3. You should know Laplace inverse of 1 over s minus a, that is equal to e power at. So if you put a is equal to 2, that would give you Laplace inverse of 1 over s plus 2, that would give you e power minus 2t. Okay, right, and the second one is, so you see 1 over s plus 3, so that will give you Laplace inverse will be e power minus 3t. So solution of this differential equation will be 9 e power minus 2t minus 7 e power minus 3t. Okay, if you want to find a general framework for this specific second order differential equation, so what do? We consider a linear equation, non-homogeneous linear equation, a y double dash plus by dash plus cy, that is equal to f of t, which is f of t can be 0, it can be non-zero. If f of t is 0, in that case the differential equation become homogeneous, whereas if of t is non-zero, it will become non-homogeneous. We will be considering both cases. With the initial conditions y naught दिस इज द वैल्यू ऑफ वाई एफ जीरो एंड इट इज़ y1. अच्छा, अब ध्यान में रख लें ये चीज़ हम आगे यूज़ करेंगे क्योंकि मैं जनरल फ्रेमवर्क को यूज़ करूँगा डायरेक्टली सोल्यूशन के लिए. वी आर नॉट गोइंग अप्लाई दिस Laplace on both sides and solution for Laplace of y or blah 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 blah. So I'll be simply using these values a, b, c, f of t, y0 and y1 in a formula to find solution of a differential equation directly. We don't need to do all the steps again and again. So in general framework, again, the steps are same. We'll be applying Laplace transform on both sides, right? So we'll be getting a Laplace of y double dash plus b Laplace of y dash plus c Laplace of y, that is equal to Laplace of f of t. Okay, and then using formulas for Laplace of y double dash, Laplace of y dash, and obviously Laplace of f of t, which would be replaced with f of s. So putting the values, a Laplace of y double dash, you see that's the Laplace of y double dash value from here to here. Okay, and this is Laplace of y dash, this is Laplace of y, and we can simply write Laplace of f of t as f of s. And then combining all these coefficients together, Laplace of y of t, Laplace of y of t, Laplace of y of t, which give us what? As square plus bs plus c into Laplace of y minus what is the value? You simply multiply with the a. So we have minus as, y of 0 is given as y0, so we just simply write a as y0. Again, it's a and y dash, that is y1, so simple write a y1 minus b y0 from here. Because of y0 is y0 multiplied by b, so we get minus b y0, and that is equal to f of s. Now taking everything to the right except the term containing Laplace of y, right? So what do we have in this case? We'll be having like right, and solving for Laplace of y. So we have simply Laplace of y is equal to as plus b y0. This one, you see, as plus b, combining these y0 together, minus a y0 y1, which will be taken to the right side to become plus a y1, and then we have plus f of s, which is on the right side, dividing both sides by what? That is a s square plus b s plus c. अच्छा, अगर आप इसको ज़रा थोड़ा सा केयरफुली देख लें, ए एस स्क्वायर प्लस बी एस प्लस सी, और थोड़ा सा अगर आप जो बाकी टेक्निक्स हमने यूज़ किए थे करेक्टरिस्टिक इक्वेशन वाली मेथड को, so it is the characteristic polynomial for a second order differential equation. What do we do in that case? You should remember, इसमें डबल डेरिवेटिव को हम यूजुअली रिप्लेस करते हैं किस चीज़ के साथ? We replace that with lambda square, whereas the first order derivative will replace with lambda, and then we have replaced y with 1. So you see that a lambda square plus b lambda plus c. अगर मैं इस lambda को replace कर दूं s के साथ, तो will I not get the same exactly what I am having here? इसका मतलब है कि जो करेक्टरिस्टिक इक्वेशन आएगा, तो करेक्टरिस्टिक इक्वेशन के जो अगर हम लैम्डा को रिप्लेस कर दें या एम को रिप्लेस कर दें एस के साथ, दैट विल बी इन द डिनोमिनेटर. अब हमारा काम क्या है? हमारा काम है टू फाइंड वाई. सो इसलिए हम क्या करना है? हमें लेप्लास इनवर्स अप्लाई करना है. सो अप्लाइंग लेप्लास इनवर्स ऑन बोथ साइड्स विल बी गेटिंग वाई इज इक्वल टू लेप्लास इनवर्स ऑफ दिस क्वांटिटी. So what we'll do altogether, you will simply put the value in this formula. That's the formula. It's important. We're using this again and again, right? Just replacing the value of a, b, and f of s, y0, y1. These are the initial conditions, right? So you should you know this formula is very simple. You see as plus b plus f of s, right, and so on. So let's do an example by using to find solution by using this concept directly. How do you do that? Let's suppose we want to solve this equation y double dash minus 8y dash plus 25y. In this case, if you check what is our a in this case will be simply 1, b will be minus 8, whereas c is 25, f of t, because it's a homogeneous equation, so it's 0, which means f of s is also 0. y0 is 0, whereas y1 is what? That is 6. Now putting all these values in this formula, I've just expressed that in that way. Now putting all these values in this formula, the y Laplace inverse of a will be replaced with 1, whereas b will be replaced with minus 8, while y0 will be replaced with 0, so it means this term will completely neglected. Similarly, plus a y1, now a is 1, whereas y1 is 6 in this case, so we'll just replace it with 6, where f of s is also 0. So what do we have? After putting all these values, we will be getting what? Laplace inverse of 6 divided by, what did I do? I just want to apply some rule from Laplace inverse transforms. I just want to have a complete square here, completing square. So it is s square minus 8s plus 25 can be written as s square minus 8s plus 16 for completing square, and then plus 9, which might be expressed in the form 3 divided by s minus 4 whole square plus 9. अच्छा, अब इस ये 3 कहाँ से बना दिया मैंने? यहाँ से मैंने 2 लेके बाहर आया हूँ, क्योंकि यहाँ पे देखें 9 है तो यहाँ मुझे 3 चाहिए होगा, राइट? Now you must remember first shifting theorem, which states that if you want to find Laplace inverse of f of s minus a, that will be e power a t into f of t, right? So what do we do? In this case, our a is 4, so f s minus 4 is given as 3 divided by s minus 4 squared plus 9. And what do we do? From here we find f of s, which will be 3 divided by s square plus 9. Then we find f of t from here, which is, you see, that is sine 3t. And then by using first shifting theorem और s shifting theorem, इसी फंक्शन के साथ आप e पावर a t को क्या करना है, अपने मल्टीप्लाई करना है. तो यहाँ पर a की जगह क्या है, 4 है, so we'll be having 2 अपनी जगह पे आ रहा है, ठीक है, e पावर 4t because of the shifting s minus 4, and sine 3t it because of Laplace inverse of f of s, जब हम s minus 4 से f of s को बना देते हैं. So that's why we are having Laplace inverse of this quantity, that is equal to what? That is equal to 2 e power 4t sine 3t. That's the answer, that's the solution of this differential equation. Okay, another example, the y double dash plus y is equal to sine 2t, which is a non-homogeneous equation, right? With a non-homogeneous initial condition as well. So y of 0 is 2, y dash 0 is also, this is equal to 1. अगर हम अगेन कंपैरिजन करेंगे तो यहाँ पर a की जगह क्या होगा, 1 होगा, b 0 है because there is no y dash, so b is 0, whereas y that is has a coefficient 1, so c is equal to 1, whereas f of t that is equal to sine 2t, right? This implies f of s is equal to 2 by s square plus 4. Right, so we will be using this f of s, right, in the formula. Y0 is 2 because of this one, whereas y1 is 1 because of this condition. Now we know the formula is what? The formula is given as this one. So putting a is equal to 1, where b will be replaced with 0, y0 will be replaced with the 2, a is again, and y1 will be replaced with 1. So we have altogether a relation as 1s plus 0 into 2. That means 2s plus 1, and then 2 by s square. So we have 2s plus 1 divided by s square plus 1 plus 2 by s square plus 4 divided by s square plus 1 is what? That is 2 divided by s square plus 1 into s square plus 4. इसको हम लिख सकते हैं, अगर सिंप्लीफाई करेंगे तो 2s divided by s square plus 1, इसको हम अलग लिख लेते हैं, प्लस 1 डिवाइडेड बाय एस स्क्वायर प्लस 1 को अलग लिखेंगे. जबकि यहाँ पे क्या करना होगा, यहाँ पे पार्शियल फ्रैक्शन यूज़ करनी होगी, जिसके लिए हमारे पास फार्मूला ये है कि 1 ओवर b माइनस a, एंड देन वी हैव 1 डिवाइडेड बाय एस स्क्वायर प्लस a स्क्वायर माइनस 1 ओवर एस स्क्वायर प्लस b स्क्वायर. तो यूजिंग दिस कंडीशन हियर, यहाँ पर 2 अपनी जगह पे आ जाएगा, ये हमारे पास है a, ये है b, सो 2 डिवाइडेड बाय basically 1 divided by b minus a, so 4 minus 1 into 1 by s square plus 1 minus 1 by s square plus 4. So now applying Laplace inverse, this is 2 times cos t, this is simply sine t, this is again it's sine t, and this is minus 1 by 2 sine 2t. Okay, so if we simplify, and this become what, 2 by 3, because 4 minus 1 is 3. So altogether we'll be having what, 2 times cos t, as I said, 1 by s square plus 1, Laplace inverse is sine t, plus 2 by 3, this is sine t, and this is minus 1 by 2 sine 2t. When you simplify it, you get 2 cos t plus 5 by 3 sine t, It's 1 sine t, 2 by 3 sine t will give you 5 by 3. Whereas 2 by 3 minus 1 by 2 cancel to 2, so we get 1 by 3 sine 2t. So this is a solution of the given differential equation. Y double dash plus y is equal to sine 2t with the condition y of 0 is equal to 2, y dash 0 is equal to 1. Okay, now let's do some question. Obviously, the same concept will be used. I'll be using the formula directly from what I explained earlier. Or you can just apply Laplace transform on both sides as well. Whatever, it's up to you, whichever method you want to use. Yeah, right. So what you do is simply see y dash minus y is equal to 0. It's a first order differential equation. We may apply Laplace on both sides. Okay, Laplace of y dash minus Laplace of y is equal to Laplace of 1. Or we may just replace a is equal to 0, b is equal to 1, c is equal to minus 1, f of t that is equal to 1, so it means f of s is equal to 1 over s, and y0 sorry, that is 0, and y1 is also 0 because there is no condition, so it means y1 is also 0. So we can use these conditions in previous formula, and then you will just find Laplace inverse. Or if you want to do that by using this rule, so जो procedure हमारे पास है, अगर आप उसी को यूज करना चाहें तो ये बराबर है s Laplace of y minus y of 0 is equal minus this is minus Laplace of y is equal to 1 by s. Now y0 is 0, this is gone. We have s minus 1 into Laplace of y is equal to 1 over s. And then we have Laplace of y, which is equal to 1 over s into s minus 1, which could be used as a partial fraction. Formula use कर सकते हैं. 1 over b minus a, so यहाँ पर b की जगह है 1, so it's 1 minus 0, 1 over s minus 1 over s minus 1. And then we simply apply Laplace inverse because we want to find y, so Laplace inverse of 1 over s minus 1 over s minus 1. Partial fraction use करना ज़रूरी नहीं है, it's up to you, आप कुछ भी use कर सकते हैं. So that is 1 minus e power t is the solution of this differential equation. Okay, let's do another example, which is a non-homogeneous again with a 0 condition. So in this case, again, you can use the formula directly. This is the formula. I want to do that by this technique. So in this case, you see, if you compare this with the equation a y double dash plus b y dash plus cy is equal to f of t, with initial condition y of 0 is equal to y1 and y dash of 0 is equal to y1. Sorry, this is y0, this is y1. You can use either notation, doesn't matter. So in this case, you see a will be what? Clearly a is 0 because there is no double derivative. B is 1, c is minus 1, whereas f of t, which is equal to 2 times cos 5t, that will give you f of s, which is 2 times s divided by s square plus 25, right? Whereas y0 is 0, y1 doesn't involve in this case, so y1 is also 0. So putting all these values in this formula to get what? Y of t, that is Laplace inverse of, we are replacing a with 0, so this is gone, b with 1, but y0 is 0, so this complete term is gone. Whereas a again 0, so this is also gone. Y1 is also not there, so this is gone. So it means we are only left with f of s, which is 2s divided by s square plus 25. Okay, whereas in the denominator we'll be having characteristic equation, that is s square, s minus 1 simply. So we have s minus 1 because a is 0, b is 1 and c is minus 1, so we have s minus 1. Or this could be written in the form Laplace inverse of 2s divided by s minus 1 into s square plus 25. Now this Laplace inverse can be found by using either a partial fraction, or you can use convolution as well, convolution theorem. So let me do that by using convolution theorem. Okay, so this is 2 times Laplace inverse of 1 over s minus 1 steric, Laplace inverse of s divided by s square plus 25. That means 2 times e power t steric sine 5t. And then by using convolution, it can be integrated 2 times integral from 0 to t e power tau into sine 5 t minus tau d tau. And then you can simply use a formula for what? That's integral e power ax sine bx is equal to, that was, if we should remember that, 1 over a square plus b square e power ax, that is a cos bx plus b sine bx. By replacing according to the values, you will get simply this integral. And that will be the solution of the given differential equation. You can use partial fraction as well by using the shortcut method. You know how to do that. Whichever method you want to use, you can do that. Okay, the next one is a second order differential equation now, and it's a homogeneous differential equation. Again, we can use the formula, right, which is AS. In this case, you'll be replacing A with 1, B with 5, C with 4, and F is 0, so it means f of s is also 0, whereas y naught is 1, while y1 is 0. So we replace all these values here, so we get y of t, that will be Laplace inverse. Okay, a की जगह क्या put करना है? 1 put करना है. So we get 1 into s, whereas y naught is 1. So 1 into s plus b, which is equal to 5. So it's s plus 5 into y of 0, y naught, that is equal to 1, plus ay1. So ay1 is 0, that becomes 0, plus f of s is also 0 because f of t is 0, divided by as square, that is s square plus 5s plus 4, the characteristic equation altogether. So we get at the end we will be getting what? That's the Laplace inverse of s plus 5. If I do factorization, तो यहाँ पे आ जाएगा ये s plus 1 and s plus 4. And then by using shortcut method for the factorization, partial fraction के लिए, तो हम क्या करेंगे? पहले केस में s plus 5 divided by s plus 4 at the point s is equal to -1. इसको छोड़ना है s plus 1 को, और वो साथ में आप लिख लेंगे 1 over s plus 1 plus again s plus 5 divided by now s plus 1 at s equal to -4, right, into 1 over s plus 4. So if you put these values, -1 यहाँ put करेंगे तो आ जाएगा हमारे पास 4/3 1 over s plus 1, और यहाँ पे जब हम -4 को पुट करेंगे तो आ जाएगा 1 by -3, so it's -1/3, and this is what? This is 1 over s plus 4. After applying linearity property of Laplace inverse, हमारे पास आ जाएगा 4/3 e power minus t minus 1/3 e power minus 4t. So that's the solution of this differential equation. Okay, next is y double dash plus 9y is equal to e power t. Again applying, but in this case we are having a non-homogeneous differential equation with homogeneous initial conditions. So applying the formula, again the formula is given as yt is equal to Laplace inverse as plus b. लेकिन यहाँ पे जो भी कोफिशिएंट्स हैं उनकी वैल्यूज़ को अगर हम डिटरमिन करना चाहें तो a की जगह 1 आएगा, b यहाँ पे 0 है, c यहाँ पे 9 है, f of t, that is e power t, which basically means f of s, that is 1 over s minus 1, y naught and y1 both are 0. So putting all these values in the equation in this formula, you'll be getting what? Y of t, that is equal to Laplace inverse of, you see y naught is 0, y1 is 0, so these two terms will be neglected. So we'll be only having f of s, which is 1 over s minus 1 divided by as square, that becomes s square, bs will be 0 plus 9. So you have s square plus 9. So this might be written as Laplace inverse of 1 over s minus 1 into s square plus 9. Again, you can do factorization, partial fraction, or you can go for convolution as well, right? If you know the shortcut method for finding these values, so it's okay. Otherwise, you can go for convolution as well. So that can be written as Laplace inverse of 1 over s minus 1 steric convolution Laplace inverse of 1 over s square plus 9. That means e power t steric 1 by 3 sine 3t. And then by using definition of convolution, it is integral from 0 to t, and this is 1 by 3. We get e power tau, and then we have sine 3 t minus tau d tau. And then again the same applying rule, e power ax into sine bx dx rule can be used to find this integral, and that will give you the solution of given differential equation. Okay, let's solve this fourth order differential equation as well. So we can go for third order as well with these conditions. इस तरह का equation usually use होता है हमारे पास जहाँ पे भी beam involve होते हैं, तो mostly इसमें conditions zero होते हैं. Fourth order differential equation आता है. So applying Laplace transform, in this case Laplace of y fourth order derivative minus Laplace of y, that is equal to 0. We are having homogeneous equation. Now putting the value of Laplace of fourth order derivative, which will be s power 4 Laplace of y minus s cube y0 minus s square y dash 0 minus sy double dash 0 minus y triple dash 0, where all these values are 0 minus Laplace of y, keep in mind, is equal to 0. This is 0, this is 0, this is 0, whereas this value is what? That is equal to 2. So putting all these values together, we have s power 4 minus 1 Laplace of y is equal to 2. That's the value of y triple dash if we replace this with 2. So that will give you what? It will give you Laplace of y is equal to 2 divided by s power 4 minus 1, which might be written as 2 divided by s square minus 1 into s square plus 1. And then by using shortcut method for the partial fraction, it will be 2 divided by 1 plus 1. 2 divided by b minus a, यहाँ पर b 1 है और a जो है वो minus 1 है, okay, into 1 over s square minus 1 minus 1 over s square plus 1. So we just cancel these together, this one, and then we apply Laplace inverse. So y is equal to Laplace inverse of 1 over s square minus 1 minus Laplace inverse of 1 over s square plus 1. That is, the first one is sine hyperbolic t, the second one is simply sine t. We can convert that to exponential as well. That is 1 over 2 e power t minus 1 over 2 e power minus t minus sine t, which is the solution of the given differential equation. Right, so if you have any question, thank you very much for being with me for so long. Don't forget to like, comment, and subscribe to my channel. Thank you very much. See you in